Hello. In this video, we're going to go over problems 1 through 3 from the North Carolina Released Common Exam for Math 2. To find out more information about this common exam and other common exams, you can go to this website right here, and if you follow the links for released, you can actually find the PDF that these problems come from. Let's get started. The equation s equals 2 square roots of 5x can be used to estimate the speed s of a car in miles per hour, given the length in feet x of the tire marks it leaves on the ground. A car traveling 90 miles per hour came to a sudden stop. According to the equation, how long would the tire marks be for this car? So, in any word problem like this one, the first step is to do what I just did and read it. And then we're going to go through and we're going to pick out key information. So our equation, any kind of equation is probably important. Sometimes they throw one in there that just to be random and try to mess you up. Variables are usually important as well, and what they represent. So S is the speed of a car, and X is the length of the tire marks. Sometimes the units of measure for each variable and other things are important as well, because sometimes you have to convert. So the speed is going to be in miles per hour, and the length is going to be in feet. All right. This particular car is traveling 90 miles per hour when it came to a stop. And we want to know how long would the tire marks be. All right, so that's the stuff. Let's put it all together now and see if we can figure out how to tell how long these tire marks would be. Well, they already tell us that the car was traveling 90 miles per hour, so my speed is 90. So to figure out the tire marks, I have to plug it into my equation that relates speed to tire marks. So I'm plugging 90 for S. So I get 90 is equal to 2 square roots of 5x. And this is what we call a radical equation. It's a radical equation because x is in the radicand. The radicand is the part underneath the radical. So we got to get the radical by itself before we can get the x out. It's kind of like the prison. We got to get rid of the guard before we can bust it out. So we're going to divide both sides by 2 to get rid of that 2. We get 45 is equal to the square root of 5x. Now I can get rid of the radical by raising both sides of the equation to the index. The index for this one is 2, so I'm going to square both sides. All right, so square root squared cancels out. I'm left with 5x on that side. 45 squared is 2025. So my last step, divide both sides by 5. And I get x is equal to 405 feet, which is C. Number 2. The heights of two different projectiles after they are launched are modeled by f of x and g of x. The function f of x is defined as f of x is equal to negative 16x squared plus 42x plus 12. The table contains the values for the quadratic function g. What is the approximate difference in the maximum heights achieved by the two projectiles? All right, so in this one, we've got two different projectiles that are modeled by f of x and g of x. F of x is this equation right here, and this table represents g of x. We want to find the difference in the maximum heights. All right, so these are two projectiles. Projectiles are always going to follow this curve right here, which is called a parabola, which is an example of a quadratic function. In this case, they actually tell us that g is a quadratic function. They give us one quadratic function, but the other one they give us the data in the table for. So we've got to figure out how to go from this to an equation to figure out the maximum heights. All right, so we could do this by hand, but since this test is calculator active, I'm going to show you how to do it in the calculator. All right, so I'm going to be using the TI-84 Plus calculator with the newest operating system on it. I'm just going to show you pictures because if I run the calculator, it doesn't get along with the recording. It messes up and freezes. And until I figure out why that is, I'm going to just show you pictures. So the first step is to turn on your calculator and go to Stat. After you go to Stat, you'll see a screen like this, and you go to option number 1, which is Edit. You'll see a screen that looks like this, except for without numbers. If there are numbers in it, you can go up to the top and hit clear. Don't hit delete, hit clear, and it will clear out the numbers. So after you do that, you put in your x values into L1, your y values or your output, in this case it's our g of x, into L2. And then we're going to press stat again. Oh, also, make sure you hit enter after that last number, or else it might not register that you put it in there. Then you hit stat. And this time, instead of editing, we want to calculate something. So press the right arrow to get to calculate. And we want a quadratic equation for this data. So we're going to go to option 5, which is quadratic regression. This gives us an equation for the data. Now, if you're using the newest operating system on TI-84, you'll see something that looks like this. And we need to go down to calculate and hit enter, and it will tell us our equation, like this right here. If you're using a older version of the TI-84 or even a TI-83, you'll see something that says quadrag and maybe some other things. You just hit enter and it tells you the exact same thing. So here's our equation. Our A value is -16, B value is 40, C value is 9. So now we're going to take that back to our problem and finish the problem. All right, so g of x equals, the A value was -16, so it's -16 x squared. The B value is 40, so it's plus 40x. And the C value is 9, so it's plus 9. Now we have to find the maximum heights for each equation. That way we can find the difference in the two. So to find the maximum height, it occurs at the axis of symmetry for your parabola. It occurs at the axis of symmetry right there. So what we're going to do is we're going to find the x value for the axis of symmetry. Then we're going to plug it back in to the equation to figure out the height. All right, so for f of x, I'm going to do this in green. For the f of x, the axis of symmetry is x is equal to the opposite of b over 2a is how we find the maximum, or the axis of symmetry. Opposite of b over 2a. This is your axis of symmetry. Let me make that clear. All right, so we've got x equals the opposite of b for this case is going to be -42. And it's over 2 times a, which is -16. All right, so that gives me -42 over -32, which reduces the top and the bottom are both divisible by 2, and it's negative by negative, so that's going to be 21 over 16. So then I take and I plug that back into f. So we find f of 21 over 16. So that's going to be -16 times 21 over 16 squared plus 42 times 21 over 16 plus 12. Okay, and when you do all the computation there, you get 39.5625. Now I'm going to do the exact same thing for g of x. So in this case, our axis of symmetry is going to be x equals the opposite of b, which is going to be -40 this time, over 2 times the opposite of, or not opposite of a, just a, which is -16 again. I don't know why my 6s are looking weird, my 4s are looking weird too. Please excuse the bad handwriting. I got a new tablet. I love the tablet. It's just taking some getting used to. So we've got -40 over -32, which reduces. 8 goes into both the top and the bottom, so that's going to be 5/4. So now we find g of 5/4 to find the maximum height for this projectile. All right, so it's going to be -16 times 5/4 squared plus 40 times 5/4 plus 9. All right, so when you do the computation here, you get 34. So to find the difference, I simply subtract 34 from 39.5625. All right. When I do that, I get 5.5625. All right, so the approximate difference in this, I'm going to round this to the nearest tenth because the answer is rounded to the nearest tenth. All right, and that 6 makes it goes up, so it's going to be approximately 5.6. So the answer to this one is D, 5.6 feet. All right, number 3. A city map is placed on a coordinate grid. The post office is located at the point 535. The library is located at the point L, 1510. And the fire station is located at the point F, 925. What is the ratio of the length of PF to the length of LF? All right, so in this one, they give you graph paper for the exam. I'm just going to do a quick little sketch because all I need to know is uh, what it looks like so I can kind of figure out the distances. Now, all these values are all positive, so my graph's just going to look like this. Alright, so the y values go up to 35, so I'm going to do these by 5, 10, 15, 20, 25, 30, 35. Alright, so each of these goes up by 5. Alright, and then the x values go up to 15, so I'm just going to do the same thing. I'm just going to kind of spread them a little more. It's 5, 10, 15. Alright, so point P is at 5, 35. It's right here at point P at 5, 35. Point L is at 1510, which is right there. And point F is at 925, which is right there. All right, so we want to find the ratio of length PF, which is this one, to the length LF, which is this one. So we want the ratio of this to this. All right, so this we have to use the distance formula. Distance formula, as you probably remember, is the distance is equal to square root of x2 minus x1 squared minus y2 minus y1 squared. And that's plus, not minus there. This comes from your quadratic formula and the fact that you can draw a triangle to find on the axis and find the hypotenuse using this. All right, so I'm going to use 2 points at a time. So PF is going to be equal to the square root of 5 minus 9 squared plus 35 minus 25 squared. All right, and so that's going to give me the square root of 5 minus 9 is -4, so it's -4 squared plus, that's going to be 10 squared there. So it's going to be equal to 16 plus 100, square root of 16 plus 100, which is the square root of 116. All right, I'm going to leave it like that for now. I'm going to find the other ones. I'm going to find LF. LF is going to be the square root of, all right, we've got 9 and 15, so I'm going to use 15 minus 9 squared plus 10 minus 25 squared. All right, so 15 minus 9, that gives me 6. All right, and 10 minus 25 is going to be -15. All right, so it's going to be the square root of 36 plus 100 and 225, my bad. 225. So 36 plus 225 is 261. So we get square root of 261. So to find the ratio of this, you got to make sure you have it in the right order. PF to LF. So we've got the square root of 116 over the square root of 261. Okay, and that reduces to 2/3. So the answer is A, 2/3. And that's going to be the 3 problems for this video. Thank you for watching. If you have any questions, please post a comment, and have a good one.